In this lecture, we're going to go over the Depression Identification Tool. This tool identifies depressions within a watershed by subtracting the original DEM from a filled DEM. This gives us a polygon output and a raster output. The polygon output can be symbolized to show the maximum depth of the depression or the percent hydric soils within a depression, which can provide valuable information for flooding opportunities. The depression raster is also output, which can be valuable for seeing the depth of a depression. Alright, so we're back in our map document. You can see I'm using that alternative watershed again, no worries. And to begin, we come over to our Precision Conservation Practice Siting toolset and open up Depression Identification Tool, the first one in there. You can see we have 3 required inputs, 2 optional ones, which we'll go over. So we have first our unfilled DEM, that's that new DEM, so grab and drop that in there. Then there's the G-Circle raster, which this tool went and automatically found for me. And it is in the correct location, so I'm happy. And then your Z factor, which is 0.01. And then optionally, we can also include the field boundary feature class and the stream reach feature class. If we do include the field boundary feature class, that means that depressions will only be cited if they are centered within agricultural field boundary. If we include the stream reach feature class, that means that any depressions that intersect the stream reach will not be included. I'm not going to include these this time around, but feel free to do it if you think it is suitable. We'll then move on to these other inputs, which we provide some defaults for. The first one is the minimum percent hydric, and that is the percent hydric soil within a depression, and we have a default of 60%. Then there's the minimum depth in centimeters of each depression. We have 30 centimeters. And the minimum surface area in acres of the depression, and we do a 1/4 acre. Then we have 2 outputs. One is required and is automatically filled. This will be our polygon feature class of the depressions. And then a second optional output of a depression raster. I am going to create this. You don't have to, but I do highly recommend it. It can be very useful for visualizing the depth of a depression. So I'm going to navigate to my file geodatabase. We're in this watershed, and I'm going to call this DEPROS. And then, as always, I'm going to end in that 12-digit HUT code. Remember to always do this. Push save. We can see it's there. Going to the same location. Then I'm going to hit OK and let her rip. Alright, so the tool is just finished running. We've got our depressions automatically added to the map doc as well as our DEPRAS. So if we take a look at the attribute table of the depressions, we have our standard fields, and then each depression has its own ID, depress ID. We also get the percent hydric soil within each depression, as well as the maximum depth in centimeters for each one. We can choose to symbolize the depressions. We can go to symbology and quantities. Let's say we do the percent hydric first. This color amp looks alright. Hit apply. Okay. And now we can get an idea of where our more hydric soils are concentrated and where our less hydric soils are. This can be helpful for understanding which depressions would be more susceptible to flooding and potentially would be worse for farming in. We can also symbolize by the maximum depth by centimeters. Apply, okay. And now we can easily see our deeper depressions and then our shallower depressions in lighter green. And this will just be useful for understanding which depressions may be even more flood prone because water will not be able to easily escape out of these. The second output was our DEPROS, and that would be our depression raster. So I'm going to turn off my polygons for right now and open up the properties and go to symbology so we can better see these depressions. So first I'll add some color. I'll go with this one. That's fine. I'm going to change it to current display extent again and hit OK. And this just provides a more detailed view as to the elevation throughout the depressions. And this can be useful for identifying false depressions or better understanding the slipping characteristics of a depression. Here's a brief recap of everything we just did to get depression polygons and depression rosters for our watershed. In this lecture, we're going to look at the Depression Drainage Area tool, which delineates the drainage area to each depression that was calculated using the Depression Identification tool. Alright, so we're back in our map document. We're getting ready to run the Depression Drainage Area tool to make sure that we have our depressions polygon feature class that we got from the Depression Identification tool. And then optionally, I have my depth raster from that tool as well. So we can open up the Depression Drainage Area tool. You can see it's pretty simple interface. We have two inputs. The first one is that depression polygon. So I'm going to grab that, drag it in. And then our second input is the unfilled DEM. That's our new DEM. The reason it's asking for an unfilled DEM as opposed to a filled DEM is so that flow paths will stop once a depression is encountered. This way, we're not going to include any upstream depressions in the drainage area of a downstream depression, since that's our goal here, is to get the drainage area of each individual depression within the watershed. I'd also like to point out some options that you have here. Say you're only interested in a few larger depressions within your watershed and not these smaller ones. Before you run this, you can start to select these depressions using this method. Another key thing here would be to right click and go to selection and make this the only selectable layer, so you avoid what I just did, where you can see I've selected the whole watershed boundary and my buffered boundary and everything. So make this the only selectable layer. You can select individual depressions. If you hold down the shift key, you can just move along and keep selecting more. You can also go into the attribute table and say make a selection based on that maximum depth or percent hydric, whatever you wish. You could also actually edit this feature class by going in and deleting some depressions that you knew you had no interest in. If you chose to do any of these things, when you run this tool, if you have selected depressions, this tool will only be ran on those selected ones, or if you've deleted them, obviously the tool will only be ran on the depressions that remain. As of now, I'm not going to make any selections, and I'm going to leave all the depressions that the previous tool calculated and just let it run as is. So I'm going to hit OK. Okay, so the tool has just finished running. You can see all of these drainage areas that's been added. I'm going to move this below so I can get an idea of which depression they're draining into. We can go in and edit the symbology, make it more appealing. I like to change the transparency, since you can see they do cover a large area. It's nice to be able to see through them. And now when we zoom into a certain depression, we understand what area is flowing into that depression. So this can be helpful if we want to target a certain spot, maybe for treatment, if we know that a large portion is draining into it. And we can also get somewhat of an idea of areas that are more susceptible to flooding than others based on how much area does drain into there. Here's a brief recap of what we did to get the drainage area for each depression.